Welcome to this mathematics video brought to you by Up Vision Concept Academy. In this video, we'll be diving into the topic surds. And we say that a surd is the square root, the cube root, or any other root that cannot be simplified into a whole number. For example, root 2 is a surd, root 3 is a surd, root 5 is a surd, and so on. Because these numbers cannot be simplified into a simple number, unlike situations that you have root 16, the simplification, the answer is 4. So this is a rational number. But when you try to find the roots of surds, it will give you a rational number. So we just leave them like this and call them surds. Now, surd is actually really untidy. We just leave it like this and work on it as if it is algebra. We can use algebra rules to work with surd. But before we dive further into this topic, there are some key things you need to note. For example, key things to note. Okay, so if you have surd root A times root B, can be any number inside, but they are surds. You can express them as the surds, the root of A and B. Invariably, if you have root A over root B, you can also express it as root of A over B, provided that B under is not equal to 0. Okay, so we are introduced to what surd is. The next thing we have to do is to rationalize. Rationalization. What is rationalization? This term you will see it inside this topic a lot. Rationalization is just a fancy way of making surds neater in fractions. If you have a surd, in the denominator, we eliminate it by just multiplying the numerator and denominator by its conjugate. So this is another word here I'm introducing: conjugates, conjugates, conjugates. So rationalization actually has to do with, if you have a surd in fractional form, the denominator is a fraction. It's a surd form. You can eliminate that surd to become real numbers by rationalizing. That's the process. But what you do is to multiply both the numerator and denominator by its conjugate. What's a conjugate? A conjugate is just taking the denominator and the operator in between the two terms in the denominator, just change it to the opposites. If you have plus in the denominator, change it to minus. Okay, for example, if I have a denominator like this, 1 minus root 2, that's the denominator in a fractional surd. I can just change this minus to plus. So each conjugate, it becomes 1 plus root 2. This is the conjugate of this. This conjugate, I need to use it to multiply both the numerator and denominator. We're going to see that. I'm just laying the foundation. So why do we rationalize? Why do we rationalize? We rationalize because we want to simplify calculations and make the answer more presentable in the exams. So another key formula we have to also note is that if you have a surd expression A plus root B, open brackets and close brackets, A plus minus root B. If you have this like this, you understand? It's like you have difference of 2 squared. So just the answer becomes A squared minus B squared. A squared minus B, sorry, not B squared. Do you know why? Because if you take it as difference of 2 squared, this is A squared. If B root b and root b meet, the roots will disappear and it becomes just b. Normally, this one, if you want to go by the expansion, let me expand it. See, a times a is a squared. A times minus root b, a times minus root b is minus a root b. Then root b times a is plus a root b. And root b times minus root b is minus b. Why? Because root b and root b will give me just b. You can see that in the laws of indices. Remember, if this one is root b, it's same thing as saying b raised to the power half dot this one too is b raised to the power half. You see that because they are in the same base, you just take one of the base and add the powers. If you add this power now, half plus half is 1. So root b and root b is just b. That's why I have b here. I'm trying to explain it here. You know, at this point, you can do the algebra. A square minus this one minus ab and plus ab. You can do an operation on it. You can add. If you add it, it gives you 0 because minus a minus ab plus ab is 0. Then minus b. So that's why we have it like that. So anytime you see something like this, as you are doing your sort, just know that it translates into this. Okay. So this eliminates the sort in the denominator. So this is like form of like conjugate because a plus b, a plus root b, the conjugate of this is a minus root b. Why? Because I just inspect the operator in between the two of them and change to the opposite one, you know, opposite, either plus or minus. And don't use division or multiplication while considering plus and minus. These are conjugates. So if I'm seeing plus here, the conjugate will be the same term minus in between. If the operator in between the two of them is minus, understand the conjugate will now be a plus. Just retain the terms. So I'm going to quickly dive into some examples. We'll dive into some examples. Just let's go gradually. Dive into examples. Okay. So the first one I have here is say I should simplify. Simplify. Okay. All right. So simplify. Root 48. Root 48. Simplify root 48. So this one is root 48. We can do the factor. Let's break it down into its factors. So root 48 is the same thing as saying root 16 times root 3. Because 16 times 3 is 48. 3 times 6 is 18. 3 times 1 is 3 plus 1, 4. So this one is, will give me a rational number if I do the root square roots. So square root of 16 is 4. We know that root 3. So this is the equation. I'll reduce this big number into this small number. Another one, simplify by rationalizing the denominator. Number 2. We are taking this from foundation and we are moving up. Simplify 5 root 2 by rationalizing. We are going to apply what I said about rationalizing. So 5 root 2, I'm going to multiply both numerator and denominator by still root 2 so that the root 2 under will become a real number. That's the essence of rationalization. I define it. Yes, I'm trying to make the denominator real number by eliminating every trace of salt. So to do that, multiply numerator and denominator by root 2. So I can write it out so that you can know what I'm doing. Multiply numerator and denominator by root 2. So 5 over root 2 dot root 2 over root 2. 5 times root 2 is 5 root 2. That's what the numerator will be now. And root 2 times root 2 will now become 2. So this is the simpler form. The simpler form. Whenever you have a surd at the denominator, it's not simple. It's just looking clumsy. It's until you can express this expression so that the denominator will be in real numbers, in real number that is not in short form, then you have not simplified. Okay, so we move on to the next one. So we move on to a more complex one. I can just take this one off. Okay, so I have simplify 3 over 2 plus root 5. 3 over 2 plus root 5. This point, I'm going to look at it, inspect the denominator, and see that my denominator has a surd here. So what I will do is to get the conjugate of this. The conjugate of 2 plus root 5 is equals to 2 minus root 5. Why? Because I just changed the operator here, plus to minus. So this is the conjugate. This is the conjugate. So this is the conjugate. So I'll just multiply numerator and denominator by the conjugate. 3 times conjugate 2 minus root 5 over 2 plus root 5 times 2 minus root 5. You see, the same thing I'm doing to the numerator that I'm doing to the denominator. I am multiplying it by a constant term, which is the conjugate. Why am I using conjugate? You can say I want to put another number, but I will be the same thing. If the essence of putting the numbers up and down will not result to this denominator to be real number, it's not worth it. That is why we use conjugates. Okay, so for the numerator, 3 times 2 is 6. And minus, this is 3 root 5. You see, we are taking this as if it's algebra. So for this one, I told you, just take this term and this term, square, that's multiply them together. 2 times 2 is 4, minus, then this one, take one of it, 5. So the answer is 6 minus 3 root 5 all over minus 1, or minus 6 plus 3 root 5. How does it become like this? When this minus multiplied through, that is minus 6, then minus times minus become plus. So this is the simpler form of that expression. All right. So we still go ahead. I have another one I want us to work together. Let me just put it here, number 4. Number 4. So they say simplify root 3 plus 2 all square. Root 3 plus 2 all square. So we can also apply the rule of expansion to expand this. Either you write it down, you can write it down. That's, again, root 3 plus 2 times root 3 plus 2. Again, that's the same thing. So root 3 times root 3 is 3. Plus root 3 times 2 is 2 root 3. Plus 2 times root 3 is 2 root 3. And 2 times 2 is what? 4. So here, I can do the algebra. This is 3 plus 4. They are like terms. 3 plus 4 is 7. Plus 2 root 3 plus 2 root 3. I can add them together because they have a common root 3 root 3. 2 root 3 plus 2 root 3 is 4 root 3. That's 2 plus 2 is 4. 4 root 3. So this is the simplest form of this expression. Okay. So we are going further. Going further, going further, going further. So I have this one here that says solve. Solve 50 plus 2 root 2 minus 18. Minus root 18. Minus root 18. Okay. Now before I go, I inspect. You see, I want to bring all this expression to the point where I have the lowest surds. So I can do algebra on them, I can add them. I cannot do this one. I cannot add 2 root 2 to root 50 because root 50 and root 2 are not the same thing. I cannot work on this one together because root 18, they are all different. So I want all the surds to be as much as possible to be the same point. So I take this first term. I can simplify this first term. This first term is root 50. How will it look like? Root 50 is the same thing as saying root 25 times root 2 because 25 times 2 is what 50, so it's the same thing. And this one can now become 25 square root is 5 root 2. So this first term I have put it in the form of root 2. The last term again, I'm interested in that one, root 18 is the same thing as saying root 9 times root 2. You see, 9 times 2 is still 18, so they are the same thing. This and this are the same thing. I'm not telling anybody. So root 9 is actually 3 root 2. So I have succeeded in expressing root 50 in this form, that is in this form, and root 18 in this form. So I can just put all what I have here in this expression. So to solve it, so simplify it, root 50 becomes 5 root 2 plus this same 2 root 2 minus root 18 becomes 3 root 2. I cannot do algebra. They are the same thing. They're having the same roots. So like when we talk about in algebra, we say when you have the same alphabet A, you can add them. So I have root 2, root 2, root 2. I can do the sum and subtraction. So 5 plus 2 is 7. 7 minus 3 is 4. So everything is 4 root 2. Answer. Okay, I have another one. They said I should rationalize number 6. Rationalize. Rationalize 1 over 3 minus root 2. Now, rationalization, I said first thing you do, look at the denominator and get its conjugate. Get its conjugate. The conjugate of 3 root 2 is what? Who can guess that? Put it in the comment section as I'm writing. Conjugate of 3 minus root 2 is equals to 3 plus root 2. So this conjugate, I'm going to use to multiply numerator and denominator. Okay, so this one becomes 1 dot, my dot is multiplication. 1 dot 3 plus root 2. Please know that that's what, let me just put the bracket here. All over, denominator is 3 minus root 2, then times 3 plus root 2. Notice what I'm doing. I am multiplying both the numerator and denominator by the same thing. And that thing I'm using to multiply them is the conjugate of the denominator. Please take note of this. Is the conjugate of the denominator. So I'll do the sum, the mathematics. The upstairs my numerator. Upstairs here is 1 times 3 is still 3 plus root 2. And here, remember what I told you, for conjugate, just multiply this by this and minus, just take one of. Okay, no, you have to do this. This is not the same thing. You have to do this. Okay, so all over. Okay, so 3 times 3 is 9. 3 times 3 is 9. Then 3 times root 2 is 3 root 2. Minus 3 times 2. No, this is still root 2. Sorry. This is still root 2. All right, so 3 times 3 is 9. Then root 2 times root 2 is just 2. All right, so we go ahead. So we have 3 plus root 2. This is root 2. Write it very well. All over 7. So this is the answer for this simplification. So I hope you are enjoying this um, class, this video. Please, I want you us to subscribe to our YouTube channel. Please subscribe so I can get notifications for more videos. Like and comments, make some comments so that we can get feedback from you and know how to present or what else to teach you. So we are going to the next question quickly. I'm just going to quickly take this off so that I can put the next question on the board. So this one is saying simplify root 12 minus root 8 all over root 3. Simplify root 12 over root 8. Sorry, root 12 minus root 8 all over root 3. Now again, I can just inspect which one is the lowest sort here, root 3. Can I simplify everyone here to the lowest sort? Yes, I can. I can. I can. So for this one, root 12, the lowest sort there is root 4 times root 3, which is root 4 is 2, root 3. So this is root 12 simplified. And root 8 simplified is the same thing as saying uh, root 4 times root 2, because 4 times 2 is 8. So root 8 is the same thing as saying 2 root 2. So I can put this one for this and this one for this. So going ahead, I can now say 2 root 3, because this is also root 12, minus 2 root 2, which is also root 8, 2 root 2, all over root 3. Now, I can do simplification by rationalizing. Now, what will I do to this denominator so that there will be no salt again on it? There will be no root again on it. I can just multiply this by root 3 and this by root 3, the same thing. You understand? We're not talking about conjugate this time around because it's not a compound. It doesn't have two terms, just one term. So, but the essence of rationalization is to ensure that you look for something to do to the numerator and denominator so that the denominator square root or any roots under it will disappear. Okay, so at this point, I can now say root 3 times 2 root 3 is the same thing as saying 2 times 3. Why? Because root 3 times root 3 is 3 minus this times this is the same thing as saying 2 root 6 all over this time this will be 3. So this here is 2 times 3 is 6 minus 2 root 3 all over 3. So this is the answer. This is the answer. We cannot do another simplification. We can actually multiply this. Hold up. This over. This over 3. We can actually multiply and divide both the numerator and denominator by this. That is what I mean is that I can just say 6 over 3 minus 2 root 3 over 3. So this cancels this. I have 2 minus 2 root 3 over 3. Whatever you see in your options, if for instance you are doing exams where you need to pick from options, you should be able to toggle between here and here. So this is the answer, or this is a simpler form of the answer. All right, so we'll just take one more complex one. We'll just take one complex one and we'll just wrap it up. So I'm going to solve this. Finally, solve this one. So if we're asked to solve number 8, solve root 7 minus 1 over root 7 plus 1. So that's to rationalize it. You see, I look at the denominator again and see that I have root 7 plus 1. What is the conjugate of root 7 plus 1? Conjugate is root. Conjugate is root 7 minus 1. So I'm going to multiply both numerator by this conjugate. So I'll write this one out again by saying root 7 minus 1, then times conjugate root 7 minus 1 all over root 7 plus 1 times conjugate root 7 minus 1. So solve, open up the bracket for the first one. Root 7 times root 7 is just 7. Root 7 times minus 1 is minus root 7. Minus 1 times root 7 is minus root 7. And minus 1 times minus 1 is plus 1 all over. Root 7 times root 7 is 7. This one is conjugate, so this is 7 minus 1. So at this point, I can do this 7 plus 1, that's like terms, add like terms. 7 plus 1 is 8. Then minus 7 minus root 1 minus root 7 minus root 7. Now, this root 7 is like the variable, the let's say our a or b. So just the coefficient there is 1, 1. So minus 1 is minus 2. Then write the root 7 all over. This is 6. So this is the answer. This is the answer. Or I can go ahead and just break it out so that it will be 8 over 6 minus 2 root 7 over 6. So that I can have it here as, how do I put it? You can have it here as fraction. That is, this is 4, this is 3. 4 over 3 minus, then this is 1, this is 3. Root 7 over 3. So this is another way of putting it. Or I can still put it like this. 4 minus 7, root 7 over 3. So whatever you have in your options. So I hope this video has been informative for you. I'd like to thank you for viewing. Please like, subscribe, and comment on this topic. We want to thank you for viewing. Have a nice day.